Welcome to the lecture series on computer science. As a part of the series, this lecture is on the introduction to artificial intelligence, and we are in module 2. In module 1, we have talked about, we have seen something on the history of AI and the topics, and from that we will proceed into the second module basically, which we will deal with the intelligent agent. What is an intelligent agent all about, and what is an agent and what makes it special as intelligent to it. And along with, when the intelligent agent is, it has to interact with the environment in the sense the surrounding that pertaining to the agent. For example, if I am the agent here, the surrounding place is the studio room. So, that is the environment. So, what are the types of environment and what are the properties with respect to environment, that is the second part. And I will also touch upon the problem formulation, that is essential on how do we make a machine to be intelligent. We have to formulate those criteria. So, researchers have identified 4 to 5 criteria as a problem formulation. We will be dealing with that. And we would see here what an agent is. This is a very simple definition that I have taken from the book on Russell and Norvig, where it says an agent is just something that acts. So, which does some action, it is an agent, like I am talking, I am an agent. So, in real life examples, we have seen something called as a real estate agent. So, the function of real estate agent is that agent is the intermediator between the buyer and the seller. A buyer will buy something and the seller would sell something, and the intermediate point is the agent. And similarly, another type of agent, here I have taken an example of the travel agent, where the travel agent is, suppose we go to the travel agent in order to book some tickets, and he knows much more than what we know, and he is going to be the intermediate point between the travel companies and us. So, we can say agent is something that is actually an intermediate and does some task. Now, the next thing is a rational agent, and adding on something agent to another term called rational. A rational agent is one which does the right thing. Now, when we talk rational, that right thing comes into place. Now, the next question is, what is the right thing? That right thing, we'll be talking that in a minute, but here we will talk what an agent is with respect to the artificial intelligence. The agent as an AI terms. In AI, we can have something like this, an agent which perceives the environment through senses and acts through actuators. Here, there are some words that I have colored in red, which is the perceive, the senses, acting and the actuators. And if you see the diagram, this is a diagram taken from Russell and Norvig. The environment, from the environment, there is a perception going to the agent, and that perception can be in many forms through sensors. For example, for me or for you, the sensors would be seeing through eyes, the sensors is eye, or hearing through ears. Okay. So, that is an example. Now, agent processes some information and acts, gives us an action through the environment through actuators, which is the hand and legs for us, but for the agent it can be something else. For the AI terms, it can be something else. So, we will be going through this actually in detail in this module. Now, if you see the arrow from left to right and from right to left, it is not only one perception, but a sequence of perception. At each second or each time frame, we perceive certain things, process something and does. So, it is actually in a sequence. Now, how do we know that what is correct? And the agent has to perceive and act in such a way that it is desirable, something is desirable, the action should be desirable, and what is desirable we can verify in terms of the rationality. And before going into rationality, we will see a small example that is again given in Russell and Norvig with respect to the agent. So, the agent here is the vacuum cleaner, and you could see the diagram here with two rooms A and B. The vacuum cleaner is in room A with some dirt in room A and dirt in room B. And there are some actions which I have listed on the right. If room A is clean, which is in square bracket, then the action that the vacuum cleaner should do is move right. If A is dirty, then the vacuum should suck. If B is clean, then it has to move left and check for the other room. And if we see the percept sequence which I described in the last slide, it would be something like if A is clean at the first time instant, A is clean at the second time instance, and then A is dirty. If that is so, then the action that the vacuum cleaner should do is it should suck. And now what is desirable? The desirable can be put in multiple ways, which is being rational. Rational is doing the right thing. And how do we determine rationality? Say for human beings the rationality is a different thing. For machines, how do we say that it is doing the right thing? One aspect of it, of being rational, is to design a suitable performance measure such that the agent could maximize that performance measure. Say for example, the rationality of this vacuum cleaner valve that we could say is at each time instance we should have a clean room. So, at all points the desirable or the rational point that we are going to make is the room should be clean. So, that is one desirable quantity or one rational point with respect to the vacuum cleaner valve. So, we can define rationality in terms of 4 factors. One is the performance measure, agent's prior knowledge of the environment. So, how does the agent perceive the previous as a sequence, actions that it can perform and the percept sequence until that particular point. We will go through each of these with that example, the same example as a vacuum cleaner. The performance measure for that vacuum cleaner is points for clean room at each time step, as I explained before. The second one is agent's prior knowledge, which means the knowledge that the vacuum cleaner agent or the robot should possess is if something is clean, then it is really clean. At the next time instance, if it is dirty, it will be dirty, and the action of it. Suppose the robot cleans that room, it sucks the dirt, then at the next instance it would be clean. So, all these information of that particular domain should be available to that agent, and the actions that each agent can perform. In this case of vacuum cleaner, the actions that it performs is going left, going right and sucking, and the percept sequence. For example, which I said in the previous slide, would be A clean and A suck. A which is dirty, which would give rise to the action that should be done as suck. So, the percept sequence for here the example is the agent has to perceive the location and also it has to perceive the dirt in a sequence, and it has to maintain some kind of a map such that where it went, how many times is it cleaned. Now, being rational, again it demonstrates to the 4 basic specification that. So, it depends on the performance that we have seen above, the environment that it pertains to, the actuators through which the actions are given out, and the sensors. So, we are nailing down that rationality to 4 aspects of it. So, here we will see 2 examples of this PEAS formulation. The first one would be the automated taxi, where the performance of this automated taxi is, for example, this automated taxi is without any driver, the taxi should be driving. In that case, the performance is going to be safe and it has to be fast, moving from location A to the goal, and it has to be comfortable, and ultimately it has to also maximize the profit. So, these are some of the performance with respect to the automated taxi, and we can have our own performance measure for the domain that we are prescribing. The second specification is the environment with respect to that agent. Here it is going to be the roads for the automated taxi, the other traffic conditions, the pedestrians and the customers. The third would be the actuators, for example, here in the taxi the steering wheel or the accelerator. The sensors, it would be the camera, GPS or other engine sensors. The second example is part picking robot. This is a robot. The task of this robot is it has to watch for the part numbers or the items and the colors, and it has to process the color and sort them in appropriate colored boxes. And for this the performance is parts in the bin which the percentage correct in each part of the bin. So, that would be one type of performance measure that we could say. Another performance measure can be, say, how many sorting happening per second or per unit time. This environment for this may be the conveyor belt, or in the case it can be the bins. The actuators is the joint arm and hands. Here in the case, here it would be the joint arms are there is no hands, but the jointed arm that is there to sort the bin. The fourth type is the sensors. Here it would be the camera and the sensors that detect the parts or the color. And having seen the PEAS specification for being rational, we would see something about the environment with respect to the agent. Agent is to interact with the environment. So, when it moves with the environment, there are certain properties that can be seen. So, these are divided into multiple varieties. The first one being fully observable environment, or whether it is partially observable. Say these are from the agent perspective. When the agent sees the environment, how can it categorize? So, the second one is single agent versus multi-agent. The third one is deterministic versus stochastic. Fourth is episodic versus sequential. Fifth is static versus dynamic. And seventh is discrete versus continuous, and known versus unknown. We will go through one by one. Fully observable versus partially observable. Here I have taken for each of it, I will give an example. Fully observable, here the complete state is known to the agent. Say for example, if you see the diagram on the right, this is a tic-tac-toe. So, suppose the one player is tic-tac-toe and another one is you. As an agent, the computer would know the entire state at place. So, this is actually a fully observable environment. Another one is partially observable. Partially observable is only one part, some part of the environment is known. Here the example I have taken is the automated taxi, where there are two taxis that I have given for representation purpose, where the idea is the one taxi, only some part of the information is known, and that information is not available to the other taxi, and there are no, this is an automated taxi where there are no drivers. So, this is a partially observable environment, and the environment keeps changing because the taxi would go in a road and that environment changes with time to time. The second type of property is single agent versus multi-agent. In the single agent, the example again I have taken is a part picking robot, where there is only one agent required, except if there are multiple agents it would sort a different one, but here it is only a single agent to do one particular task. In a multi-agent, it is an automated taxi driver, and here each of the cars is automated taxi. So, there is a multi-agent. The idea here is each agent should communicate with others, so that the collisions should not occur and it has to obey the rules. The third one is the deterministic versus stochastic property of environment. Deterministic in the sense, the next state after an action, suppose an agent does some action, the next state is known. Suppose if we take the part picking robot, the robot would place the particular color in that particular bin, and after that it knows that that particular part is actually in that bin, it is known. In the stochastic case, it is not known. For example, same automated taxi driver environment, because the environment keeps changing, the automated taxi driver would not know at next second how the environment would look like. So, it would be stochastic, it would be uncertain. Another type of the property is episodic versus sequential. In episodic, the agent is experiencing as atomic episodes, in the sense that perception is going to be only one atomic sense. Say for example, if we take the part picking robot, it sees one part and it does only one action according to that, and if it does the next action of picking up some other part number, the two actions may not be in a sequence, it does not depend, meaning the second action need not depend on the first action. This is the episodic type. Whereas in the sequential type, here the example again is with respect to the automated taxi driving environment, where one action depends upon the previous actions as well. Another type of the property is the static versus dynamic. Static environment means there is no change in the environment. Say the same example is being taken as the part picking robot, and with respect to the agent there is no change in the environment. Whereas in the automatic car driving scenario, the environment keeps changing often. Another type of property is the discrete versus continuous, where in the discrete type each state is represented as a finite number of places. Say for example, if we take chess, it is represented by the pieces of board with finite squares, and once an action is done, that state will also be known, and it is actually discrete in number. Whereas in the case of the automatic driving scenario, it is continuous, it is a continuous range interval. Say for example, car's position, speed, acceleration, these are the continuous variable, and it can take wide range of values, it cannot be made as discrete. The last type of property is known versus unknown. Known in the sense it is with respect to the agent, what is the whether the agent has some knowledge or the previous knowledge of the environment, and once the action is done, does it know what it will lead to. Say for example, the chess, the rules of the games, the states of at what point that particular item was on the board, and the outcome, the action outcomes of that are all known and the predictable according to the agent. That is the known category. Unknown is it does not know the next information. For example, the vehicle navigating to a new unmapped city without any prior knowledge, because it might not be aware of the traffic conditions, it might not be aware of the potential obstacles, or with respect to other people, or with respect to other vehicles, if those are unknown. So, these are some of the properties with respect to the environment. Now, on the other side, when I started this talk, we remember the diagram with the agent as well as the environment. So far we have been talking about the environment. Now we will get into the agent. Much of the AI engineer side is to program an agent. Say I said, okay, the agent is going to perceive something from the environment, does process something and gives out as an action. So we saw that the type as an environment. Now we get the agent gets some information from the environment and it has to process. So what is that process all about is what we are going to see now. So when we talk about that agent side, it is basically categorized as different structures. One would be the simple reflex agent, second one is the model based agent, third is the goal based agent, fourth is the utility based agent, and fifth is the learning agent. We will go through one by one, and this is again taken from Russell and Norvig. The first type of the structure is simple reflex agent. Here you see the diagram where on the left side it is the agent and on the right side it is the environment. So, from the environment the agent is getting perception through some kind of sensors, and it does process and gives out actions. That is clear from the last discussion. Now, what is the process that goes inside? The process is very simple, where what is the world is like now, and based on that what action should I do now. So, those should be done as a simple reflex agent, and the helping criteria is we can have simple if then rules in order to decide that action. Here the example that we can take is the common thermostat. The thermostat, the function of thermostat is if the temperature is something say suppose it is less than 25 degrees centigrade or less than 5 degrees centigrade, then switch on the heater. If the temperature is more than 30 or 35 degrees centigrade, switch on the air conditioner. Very simple example like this will be a part of the simple reflex agent. So, if we map it, the sensor is going to be the thermometer, the actuator is going to be the heating or cooling system, and the if then rules, the example that I said, if the temperature is below or above, then turn on the heater or turn on the air conditioner. So, this is a simple example of reflex agent. Now, if we slightly modify this diagram into this structure, where in the previous structure we have what the world is like now and what action should do now. Now, we are going to have some more information with respect to the sensing side. We will have some kind of a state. State is an information that has, in computer science terms, state is something which will have a type of space as well as time. At that particular instance, how that portion was, that can be simply termed as a state. Now, with this information, how the world is evolving, and based on it what my actions do, with those information can we modify the simple reflex into this condition such that we can term it as what the world is like now. We have to modify that part, then it would be the similar thing as the simple reflex agent. And in this case, we can take the example as the robot vacuum cleaner as model based agent, where the sensors are going to be detect dirt, obstacles, and drop off. Actually, it should be it should not drop off while falling. While falling down the stairs. Okay, it should not fall off. So, that is the actual the meaning of drop off. Then the internal model, that is the state, how world evolves, what my actions do, that can be mapped to the internal model, where the vacuum cleaner maintains an internal map of an area that it has cleaned, and what are that it has to, what are the areas that it has to clean. All those can be mapped into the how the world evolves and what my actions do. Another one is the actuators. Here the actuators is the wheels to navigate, the brushes to sweep, and sucking portion. Of course, the if then rules which we have seen there, if the room A is clean, move right, if the room B is clean, move left, and so on. If we slightly modify this model based agent into some goal portion, then it is a goal based agent. This is a diagram for the goal based agent, where if we see it is very similar to that of model based agent, except that below sensors what is the world like now, and below that what it would be like if I do action A. That was missing earlier. Here we have one more block, which is after doing one particular action what will be the outcome. And if you see the arrows to the left, how the world evolves, what it will be like if I do action A, what do my actions do, that will go into the percept sequence. So, all those, and that would actually be aligned with the goal. So, along with the goal, if it is aligned, then it is a goal based agent. An example of it is the drone delivery system. In this case, the goal would be to deliver at the exact location where the user has specified. So, that would be, and at each point while it is flying, it has to remember that what it would be like if it is going to deliver at that particular point. So, another type of agent is the utility based agent. In addition to goal, it would be talking about some kind of happiness. So, if you look at this picture, it is very similar to that of the goal based agent, except that the goal is missing here, and there will be the happiness criteria coming under the third block below the sensors. After doing each action, we have to evaluate and check how happy will I be in such a state, and that would lead to the utility. An example here we could think of is the autonomous taxi, and here the utility would be the maximize the passenger satisfaction with respect to travel time, fuel efficiency and passenger comfort. Here again the goal is only to reach from point A to point B. In addition to that, the utility at each point would be the maximize the passenger satisfaction or travel time. Okay. The last type of agent is going to be the learning agent, where on the left side you could see the critique, and we have set some standards already. The performance, this is slightly modified from the previous diagrams, where we would have set some standards as a performance standard, and there is a critic at each stage who would say something about that, and that critic would give a feedback, and based on that feedback there is a learning element, and this mostly would come under the learning category, the machine learning categories. This learning element would take all that and learn, again measure the performance, and with the performance it gives back the knowledge to the learning element in order to learn by itself, and it sends the actions through actuators down to the environment. Now, in addition to this, if you see down towards the left side, after the learning goals, it is a problem generator, meaning it has to give something new to the user. In the sense, it has to generate some new design to the user. It should be generative in the sense. So, an example here I could take is a personalized news recommendation, or another analogy like I could say is we all watch YouTube on your mobile phones. Suppose you have watched one YouTube video on the mobile phones, the next time when you watch something very similar to that content pops up. You can take that example here. The sensors is number of clicks, what is the reading time, or in the case of YouTube it would be the viewing time. Actuators, displaying relevant news articles, or on the YouTube it would be display relevant YouTube videos. The learning element here would be the multiple machine learning algorithms that they will be using. The performance element, it is the decision rules for recommendation of that particular articles. So, which article or which video should be available to the user based on his criteria. And the critique, it is the feedback from the user interactions. Say for example, clicks, the number of clicks you make for the YouTube, a number of shares you make it through YouTube, the likes to it. Okay. All these are going to be the critics which form the interaction from the environment. And the problem generator here, this is the new thing that is coming up. So, based on these factors, can you design say condense the user preferences so that you can show it for the next time when the person is viewing, you can show that YouTube link or that content. So, this is the problem generator portion. So, these whatever we have seen so far is the different types of agents. So, in this module first we saw about the agent, the rational agent, the environment types, the properties of types, and then the different types of agent. And having all these, we will now go into how to solve a problem and why is it needed. Okay, we know, okay, our whole job now is to design an agent for certain problem. Now, in order to design that agent, we have to specify certain criteria, and that is called as a problem formulation. And researchers have identified 4 to 5 points. One would be the state or the number of states. The second is going to be the initial state at which the agent is. The third is the goal state or the final state where the agent is going to go at the end. What is that user actually wants or agent actually wants. Fourth is the actions. At each point, if the agent does an action, what will happen next? And finally, the cost of moving from one to other, it need not be in rupees or currencies, but it can be in terms of some of the cost like the distance. Okay, we will be going through each one of it in the next few modules. To close, in this module, we have covered the agent and what is rational about it, what is right about it, and being rational, we brought about 4 specificity with respect to the performance, environment, actuators and sensors. If we define certain things, then we can say we can design something as an agent. And talking about the agent with respect to the environment, the properties of environment can be divided into multiple types, those we discussed, and the structure of agents as simple reflex, model based, utility based, goal based and learning agent types. And finally, we have given an introduction to the problem formulation. Now, before we close this session, there are some questions for you to ponder upon and work, which we would also be addressing in the next module. The first question is, describe the type of agent used in an autonomous robotic vacuum cleaner. The second question is, what type of agent would be most suitable for a personalized e-commerce recommendation system and why do you think so? The third is, compare and contrast discrete and continuous environment with examples from real world settings. Just think about it, write it down and we can discuss it in the next class. And in the next module, we will go through in detail about the problem formulation examples, and with that beginning we will get into the search type, and pretty much we will start with the uninformed search, which is essential for the foundation of the entire AI to progress upon. Thank you.